Okay, yeah, that'll be us.
Yeah.
Okay, we're in business. We're recording.
Nice.
Well, thanks everyone for joining. Today we have Abhishek, and we're going to talk about a synthesis study that is hopefully becoming a manuscript soon, or is in some stages, but we'll hear more from Abhishek. And then after that, we'll have an opportunity to talk about other possibilities for collaboration and future, how we want to structure our future meetings together. So Abhishek, do you want to try sharing your screen again now that I changed settings? Make sure that's still working.
Yeah, it should still be fine. I'm just going to turn off my video because it's just easier. Okay, and you guys should be seeing my full screen or
Yes,
full the
looks
PowerPoint
good.
slide. Okay, so yeah, thanks John and Jenny for kind of being patient. I know we tried to schedule this a couple of times and then it sort of wasn't working out primarily because of my schedule. So this is going to be an update on this carbon budgeting activity that we started really a while back. This was part of sort of the original set of synthesis activities that were started in preparation for phase 3. But then, and then there were like 4 or 5 different studies that had started. A couple of them have been completed. I think a couple of them haven't necessarily gone forward. This one has kind of been lingering in the background. Uh, we hit some pretty significant challenges or sort of bottlenecks in terms of getting specific data sets, but I think we now have sort of a path forward. And so this kind of figure here is really symbolizing the long and tortuous road that some of us kind of have been taking in trying to put this together. A big shout out to several people who have contributed. I don't have everyone listed here. This is like, if I start looking at all of the list of contributors, it's easily almost like a 50 author paper, given all of the different modeling contributions and everything. But certainly a big shout out to John, and then Geraldine Poe, who was like a summer intern on this and is now a PhD student at Northern Arizona. But then significant inputs from lots and lots of people, including many, many modelers who I haven't even listed here. So kind of what I'm just going to quickly run through is sort of what I call as like version 1 of the carbon budgeting activity. And this would primarily just give an overview of like what our main motivation was, like the initial paper outline that we had, some of the preliminary results we were obtaining. But then sort of like really where things started unraveling was when we tried to put together the carbon budget for the entire domain. And we kind of came across a bunch of different pieces that were missing, uh, several of which were in preparation by different groups, but really no concrete data existed. However, I kind of will then switch quickly to, I have just like one or a couple of slides on the GCP Recap 2 permafrost study that has been going on for the last year or so. And as part, under the auspices of the GCP Recap 2 activity, we have now actually gathered a lot of data, and some of those data sets actually address those missing pieces. And so which will sort of lead me like over the last couple of months as I've started or restarted thinking about this, sort of like what I think like the version 2 of this activity looks like. And this is where I kind of think sort of end with like just plan like the timeline for like just finishing the manuscript and putting all of this together. So the original study, like when we started off, we kind of had like a very simple question that we had formulated, which was just what is the carbon balance of the above domain and how has that responded to environmental change over the past decade? We kind of had just focused on like a 10-year period between 2009 to 2018. No real good reason for doing this other than the fact that I did want to use top-down inversions that used a lot of the satellite data. And since the main satellite era that we have for CO2 at least starts from 2009 when the GOSAT satellite launched. So I kind of just started the clock from there. But honestly, this can be shifted to like a 2010 to 2019 or anything else. And I'll sort of talk about that. I think in version 2, we now have the option of actually extending this both backwards as well as like um, adding a couple of years at the end here. Um, the idea was that we would look at three different types of flux estimates, data driven, which are kind of primarily data driven, or like what's also known as like the upscaled flux estimates from flux tower data, bottom up, which is primarily like the process based models, and top down, which would be the atmospheric inversions. Um, and then one of the things was that we kind of didn't just want to look at the entire domain as a whole, but we wanted to break it up into specific biomes or ecoregions. And so we used the EPA ecoregion definition and sort of came up with like a set of specific biomes that we would look at. And then temporarily, we would look at like both the annual as well as the growing season. At that point, when we had started this discussion, this was again 2020, 2021, recap 2 was kind of just about spinning up. And so we did have it at the back of our minds that we would want to interface with recap 2 if possible. But this was kind of pretty nebulous at that point, I would say. The paper outline that kind of John and I had crafted and that we started filling out, it's kind of like sort of a pretty standard outline for all of you. I think on this call, you have worked on different sets of any reconciliation papers, top down, bottom up estimates, or carbon budgeting activities. So we were going to cover all the different methods and then primarily just focus on like a bunch of assessment looking at the mean carbon fluxes for specific flux components, looking at the growing season and annual exchange, IAV, etc. Um, we had decided early on, or at that point, I think our decision was that we would focus primarily on CO, like on the CO2 exchange and the carbon cycle components. We wouldn't necessarily go into methane because it seemed the methane budgeting activity or the methane synthesis could be a different paper. And so we can kind of talk about that again at the end of like once we are done with the presentation. It was certainly more skewed towards top-down and bottom-up reconciliation, or at least that's like the activity that we were kind of veering towards more and more. And as I said, we specifically decided that we'll ignore the methane and into our budgets for this outline. Uh, when we were setting this up, I think our expectation was that we would have like this nice set of data sets, a nice spread of data sets across different categories. So it kind of have just like captured some of like I just went back and found like the initial notes and the initial slides on all the different data sets that we were trying to collect. So we identified several of them under like this data driven or the upscaled flux data sets. For process-based models, we have identified several, as well as like a bunch of different top-down atmospheric inversions. And as I've written, this was like kind of our expectation. The reality, once we started collecting the data sets, was kind of very, very different. This is sort of what we ended up with in the list. I think after like several months of going back and forth with different modelers and sort of trying to figure out like whether we have the particular right period, whether we have the gridded data sets for the entire domain, we sort of ended up with this sort of list. The purple ones here were the two that we got for the upscaled estimates. Then we had like a huge list, which was primarily, this was dominated by Trendy, essentially, like all of the Trendy model output. And this was version 9, which I think we can now again get an update. We had the regional ed model. We had the SIP4 that we got from Alea and Ian Baker and those folks. And then we had like some of the top-down inversions as well. Again, all of these were the global inversions, which are run at pretty coarse resolution. We didn't have any high resolution inversion. I remember having a lot of discussion. I don't know if Lay is on, I can't see the list of participants, but I remember having lots of discussion with Lay on whether we could use their carbon tracker Lagrange setup, but they had only run their inversions up to 25 2015 or 2016, and so it kind of didn't match the period that we were looking for.
We have an update, Abhishek.
Okay, awesome. Thank you, Lei. I'm glad you're on. So I'll certainly be happy to kind of pull in that update.
Okay.
And then TCF, I think that's now ready, maybe Jen, Mary. So hopefully if the TCF estimates are available, we can pull those in as well. But anyway, this is
Yes, through 2015, Abhishek, through
come on,
2022,
four more
through
years.
2022, we should be done by the end, or let's say mid-October. Is that too late?
Well, okay, we'll come back to that.
Okay, offline.
Offline, yes. But anyway, so sort of what's shown on the list here, that's sort of what you'll see a lot kind of represented in the next few slides. One of the interesting aspects were that we kind of decided it would be nice to just do a sanity check on how good these flux estimates are. And this is where a huge credit to Geraldine Poe, who was a summer intern. And she sort of, what we collected or gathered was like, talked to a bunch of different folks who run or sort of operate the eddy covariance towers. And we got like data sets from them, which primarily spanned from like 2013 to 2017. And then we did a comparison of like the different sets of flux estimates, primarily their mean against sort of the tower data. So let's say if we just pick one panel here, I'm showing like all the different 9 plots for the 9 different towers that we had. But if you just like focus on this one plot here, the Brooks Range Tundra, the black line here kind of shows what the tower observations are. And then you have like basically the ensemble spread kind of shown for the different top-down, bottom-up empirical. Now, this was, I mean, we kind of did this just as a sanity check. It was kind of just good to see specific regions where the tower data was different from the bottom up or top down. We have to remember that like the spatial scale for these top down, bottom up empirical estimates were very different, right? So for example, like most of the top down estimates, they were at a pretty coarse resolution. And so you kind of, the tower footprint is like pretty small, like let's say a kilometer, but instead you're kind of looking at an aggregate area around it of like 3 degrees or 5 degrees. So this was certainly like, I'm not saying that this comparison was like very, very robust, but as like a sanity check, I think it was important just to get a sense of like specific regions where we typically have consistency among the different flux estimates and other regions where it completely falls apart. We sort of try to do some quantitative estimation as well. So looking at the Taylor plots, where you have like the standard deviation shown on the axis here, correlation, and then the RMST sort of shown in the middle here. This black dots is sort of what the tower observations tell us, and then this scatter of like the 3 different symbols here, those are for like the bottom up, top down, and empirical. And this was kind of a good way of just noticing. So like the one shown in green here, which is Scotty Creek and Havoc Pack Creek, which basically kind of falls in this like this region here, sort of in this yellowish region here. In general, like it seemed like all of the flux estimates had reasonable agreement with like what the tower data was telling us. But then if we looked at Barrow or Atkosak, which were up in the like Alaskan tundra, essentially you could see like we were getting some flux estimates, but you can't really say that they were in any way sort of reasonable in terms of what the tower observations were telling us. So again, as I said, this was just like a sanity check. Because of the mismatch in the spatial resolution, I'm not going to put like a lot of effort in trying to interpret this quantitative numbers, but I think this was a good sanity check. This was sort of, at this point, we kind of were still focused on the top-down and bottom-up reconciliation. I'm just trying to understand how those NE estimates line up against each other. We got a little bit more ambitious and thought like, well, can we actually attempt and try to put together a budget? Now, which would require actually knowledge of certain other flux components. And we were able to pull some of this data from the global ED model that George Hurt's group runs. So we kind of use that to get information about like the harvest and some of like the crop harvest, grazing emission, wood products, etc. Although the data did not cover the full 2009 to 2018 period, but still it covered like a big chunk of that time. And we just used that 2009-2016 estimate as like estimate. But there were sort of other flux components like fires and lateral fluxes that we were missing. So we kind of tried to put together like sort of like what a budget for this activity would be. This is just sort of a schematic that I had cooked up. I think since then, discussions that I've had at ASTM 7 and ASTM 8 with people like Dan Hayes, and even had a discussion with Dave McGuire. There are like modifications that are needed to this plot, but in general, it basically captures all sort of like the major components, which includes like the NPP, the respiration, you have the fires, and then some of these wood crop products, etc. Sort of like pretty standard in terms of like carbon budget. What it is still missing is sort of like the lateral fluxes and some of the biogenic CH4. So this was sort of like the very first attempt at trying to put together like what the NPP respiration NE numbers we were getting from the data sets that we had that I mentioned earlier. And then just as a comparison here on the right-hand side, I've captured the numbers from McGuire et al. Paper from 2018, but which focused only on Alaska and then looked at this much longer time period. So the numbers are not, again, directly comparable, but again, just to sort of establish like where the above domain and this 10-year period kind of sits. And that, I would say, that kind of has been a big challenge. Like when John and we have looked at sort of the past literature and tried to look at like the different domains or sort of the different time periods that these carbon budgeting estimates have been attempted for, they are kind of all over the place. A lot of them are focused on Alaska. There are actually very few which focus on Northwest Territories to begin with. A lot of them are focused in Alaska, but in the time period sort of it's kind of all over the place. Like you have like a 50-year time period versus like 5-year versus like 10-year. And so this is sort of where we thought that really there was a big need in trying to come up with like a consistent set of estimates for like the entire above domain, but then also sort of broken up into the smaller ecoregions. Like I think there is like a real need for this kind of study to be done. But the challenge was that we were still missing some of these big pieces, flux components. So fires was like a missing block. And I remember having this discussion with John, and I think from GFED, we were kind of calculating roughly around 50, but which, as I'll show in a couple, next slide, I think that seems to be like a pretty big underestimation based on the above Fed estimates now. And then we sort of missed like this biogenic CH4, although again, those estimates were in preparation or development through LPJ, DCF, and other models. So I think this should be easily available right now. And the lateral fluxes, I mean, this kind of remained a big unknown. Dave Buttman obviously had the project sort of working on looking at a lot of like ground measurements and then trying to upscale from that. It would be worth checking in where that is. Otherwise, I think this is where like the recap 2 effort will be helpful, because we certainly have some estimates from recap 2 on like the lateral fluxes that can be used for this domain now. So there were like all of these gaps, and I think this sort of remained a big challenge where we and a couple of different ASTMs, we tried to get like estimates from people, but our estimates that were tailored to the above domain, and we really sort of hit a bottleneck. At least some of that is now covered. Fires, thankfully this came out, and as John wrote in his email, I think procrastination finally paid off for us. So we now do have these estimates from the above FADE work, and at least for 2001 or 2002 to 2019, this estimates for the above extended domain seems to be around 83. And that's kind of what I've put in here, 8 teragram carbon. But if we do actually put in that 83, all of a sudden, then basically if we start looking at any and fires together in terms of like the land contribution, it's a big question mark whether this is like a sink anymore, because this is now like a positive of 30. So, and I think this sort of gets at like, I mean, one of the questions we have had with the above domain in general has been like the net source versus sink. And I think we are certainly seeing that maybe play out a little bit, which is that in general, in terms of the uptake, it's like a net sink. But then once we start accounting for disturbances like fires, that will just push this to a source. However, there are like, again, other pieces that still need to be calculated and brought in. And then this is what I was having the conversation with Liz earlier, that I would just like to actually get like the gridded products so that we are able to apply the mask that we are using for each of the ecoregions and kind of come up with a more robust estimate for this number. But it's sort of great that we have this particular data product now. I think that actually solves like a big missing piece we had earlier. So this is sort of like kind of a summary infographic that I put together. I think I've shown a version of this at ASTM 8 or something like that, which just shows like for some of the specific particular regions, how the comparison of the different flux estimates against like the eddy covariance tower data looks like. And then sort of like just in general, kind of capturing what I said earlier, that if we start looking at NE and fires together, then at least, again, these numbers are to be updated. So please take this with a grain of salt. These numbers are to be updated, but with sort of the estimates we had before, if you bring in the fire information from above Fed, then this sort of seems to be a slight positive here. So this sort of now gets back. This is like a slide again. I've shown it at both ASTM 7 and ASTM 8 on sort of what we specifically have been requesting from the above team, from like the modeling team, the hydrology, permafrost, like any team that can provide us with estimates on like the biogenic methane flux estimates, as well as like graded lateral flux estimates. The fire emission estimates we now have, which is sort of great. And then one of the questions, I think Dan Hayes was the one who asked us this at ASTM 8, which was like, is this a top-down and bottom-up NE reconciliation study or like a carbon budget study? Because sort of, I think we have enough material and enough ammunition to kind of put together the top-down and bottom-up NE reconciliation study. But it is also like, I think from a science perspective and sort of like from the above community perspective, what would be more interesting would be like a full end-to-end carbon budget. And John and I have gone back and forth on this, to be perfectly honest, a lot. And that is sort of reflected in like the long delay with where this paper is. And I'm more than happy to have this, like kind of discuss this. Maybe there are like 2 studies, honestly, that can come out of this. But we should certainly have a discussion around this at the end. So sort of switching gears now a little bit to, as I said, like in the meantime, in the last couple of years, the activity that has been going on in the community from GCP and Recap 2 has been looking at budget for sort of different domains. And in Recap 2, for the first time, we actually have been attempting to put together a permafrost budget, which sort of kind of covers the domain for like the permafrost domain for North America, for Europe, North Asia, and a little bit in South Asia. And I mean, again, several of you on this call are already part of this study and contributed to the paper. But with Recap 2, we kind of have like a pretty end-to-end estimate of what the budget looks like for this domain, using like a whole suite of models, upscaled, process-based models, as well as like the top-down inversions from GCP, et cetera, and for all the 3 species. These numbers are kind of still being revised, but I think, again, one of the messages that's coming out from the Recap 2 study, permafrost study, has been that in general, again, the trend for the overall domain is sort of like a slight sink, but then the moment we bring in disturbances, then that just tends to push this domain into a source. These numbers are kind of still being revised because we just got some updated estimates for the top-down inversions from GCP that I received from Ingrid, as well as some of the process-based models are also being revised. But there are like three sets of papers that are kind of in preparation right now. One by Eleanor Burke, which focuses just on the upscaling method and sort of the flux estimates that come out of that. Gus is writing one which kind of does this full budgeting that I've shown here, like in this table, these numbers. And then Anna is working more sort of like on an any reconciliation, like a top-down, bottom-up um, paper. And Anna is online, so she can kind of speak more to it if we have questions. But the good thing with this recap permafrost study has been that this actually now provides us with a lot of ammunition and a lot of data sets that we can tap into. And more importantly, it actually helps us put the carbon budget for the above domain in context of like what the Panarctic carbon budget sort of looks like. So kind of as I've been working more on the permafrost study and switching gears to this one, I'm certainly starting to push this more into a decadal carbon budget study. I think that's sort of like what's really needed. Um, we can kind of certainly expand the time period. I think we have a lot of data that we can tap into, graded data sets that we can tap into to look at like 2 full decades, and which I think will be really useful information. The top-down and bottom-up reconciliation, maybe that sort of becomes like a second study, including like the comparison to the flux towers, which I think is sort of valuable. And I certainly plan to leverage a lot of the recap2 graded data sets. I still think there is still value in using data sets that are tailored for the above domain, so that we are not just using like a global fluxus. But again, it kind of, I realize that a lot of the data products like the lateral flux, et cetera, are in preparation right now. And it can be challenging. I mean, we can either just keep on waiting, or we sort of just move forward with what we have available. But in general, like the above Fed paper, and which shows that there is a big underestimation in GFET4 in terms of the fire emission, I think that's a perfect example that ideally you do want to use data sets that are tailored for the above domain. So the timeline that I'm kind of targeting right now, we have a lot of data, we have a lot of pieces. We have like pieces in the text and the manuscript that's there. So I was going to put out a call for data sets, either new ones or updates to previous flux estimates that you might have provided, like by a couple of weeks, certainly by like the first or second week of September. And then I think if I do get that with all the tools that are already there and everything, it should be pretty easy to, or hopefully, I think it's reasonable to target that the paper draft can go out basically in like another month or so. So yeah, this is sort of like a final summary of like, I know I presented like a lot of material, especially for folks who, some of you have seen this multiple times, know of this pretty well, but some of you might be seeing it for the first time. But yeah, I mean, the carbon budgeting activity, initially when we started, we kind of sort of veered more into this reconciling carbon flux estimates from the top down, bottom up, upscaling approaches. We did this comparison against eddy covariance towers, which was useful as a sanity check. But then the moment we tried to put together this overall carbon balance, things kind of fell apart a little bit because of missing information about other flux estimates that you need to put together the carbon budget. However, now with recap2, we have a lot of those data sets becoming available. They are not necessarily tailored to the above domain, but I think they'll still provide the quantitative information we need. And so I'm kind of certainly going to expand the analysis period, but hopefully, I think by the end, once we have this carbon budget done for the above domain, we can kind of put it in context of what the Panarctic carbon budget looks like. And I think there will be a nice tiered set of papers in terms of what the recap2 permafrost budget study says and what then the above budget study says. Again, haven't made a call on like whether to include like methane into our budgets fully well. I've been a bit out of the loop on where the methane synthesis study is. So maybe Jenny and Rosine, if she's online, like maybe one of you can comment on that. But yeah, that's kind of all that I have. And I'm happy to take questions.
Thank Abhishek. Thank you for that presentation. We can open it up to questions, and then I know Luke, you're on the line. So if you want to comment about the methane synthesis.
Oh, and we have 20 people. That's awesome. I didn't realize.
That is awesome.
You're popular.
Or Roisin. Oh, there you are. Thanks,
here.
Luke.
As far as I was seeing if there's any other questions specifically, but I think as far as the methane, we weren't really ever targeting kind of the larger domain scale, above domain scale. We've mostly been looking at individual kind of case studies for different regions where we have the atmospheric measurements. So we could probably relate, but they would relate in some ways, but I think largely it would be a separate study. And
So
we're
it
really
sounds
just
like
looking at individual snapshots. So that could be a target for something future, as these larger domain-wide methane budgets are available.
Yeah,
that's
and
something I could coordinate with you, Abhishek, because I'll be recruiting a new postdoc coming on for my ABoVE phase 3, and we wanted to adopt what you were doing for this study and then expand it across Canada and maybe parts of Siberia.
Okay.
So we could help with that process, especially including methane.
Okay. Yeah, and the reason I brought it up, like methane is specifically challenging, right? Because I remember when we started doing this methane budget, we kind of had estimates from the top down, but then the moment we were looking at the bottom up estimates and the process-based model estimates, it became, I think the bigger issue we identified is like what type of inundation is specified in sort of the different models, how different those are, and the fact that they were sort of didn't like necessarily match with like any kind of measurements that we have. And that sort of became a big project in itself. And
that's
out
still
on the name.
problematic. We are finding this over and over again. Just scaling's an issue with methane for sure.
Yeah. And so to me, it kind of seems like that just is like a bigger challenge. And so if we want to, which is why I'm kind of a little bit hesitant to include like a full methane budget in this, but rather just go after like the biogenic methane, which kind of has a contribution to the CO2 portion.
Agree.
Sort of like what Dave McGuire did in his 2018 paper, right? So kind of just getting that estimate, and which I think either from TCF or LPJ, we should be able to get a number.
Maybe as a side note to this, hi, I'm Anna. Thanks, Abhishek. I was looking at the methane inversion data sets, Abhishek, that you also have. There's also a lot of variability in terms of if the data is like from remote sensing data or in like concentration data. So it kind of felt like maybe we for the inversions, maybe we need like a separate inversion methane paper first to like understand those differences before we like group them together. I'm not sure what the experts think about this, but it seemed like there's a lot of variability because of that.
Yeah, and that's a great point, Anna, because all of those methane inversions that you have, those basically come from the GCP methane suite, right? And all of them are done at a pretty, again, coarse scale. A lot of them just use surface measurements, which is pretty sparse in the domain. Some of them do use GOSAT data, but it's a huge spread. I think, I mean, you have like what, maybe 14 inversions in there. And I know, yeah, the spread between them is huge. There is an updated inversion, GCP methane inversion work that's being done. And I've been talking to Mariel Sona, who runs that. So I'm hoping to get some more or some of the newer inversion estimates from her. Now, whether that will reduce that spread that you see, I'm not sure. If anything, there might be like one or two more inversions that are thrown in there, and that might actually increase the spread. Who knows? I don't know.
So far for methane, from a top-down perspective, we've found the new NOAA Carbon Tracker CH4 results to be most helpful. I think that it gives us, that framework too gives us a little more flexibility if we work directly with Lori Breweiler to adjust the system, and then we can test different priors. So that might be something that, instead of focusing on these inversions that really don't match each other very well, we could instead use that as a focus area.
Quick question. How much of the observations that are within the above domain does the carbon tracker methane use, or is it primarily continental observations?
I think it's primarily continental. Of course, above is such a small region in the context of the greater domain. But I think that we can pull, I'll have to ask Lori. I'll get back to you so I can give you a definitive answer.
Yeah, the carbon tracker methane includes all the available methane observations in the methane obspec. So for the Alaska region, it includes our long-term observation plus the Environment Canada measurements.
Do you know the total number of observation sites?
It's a lot. I don't remember
there is quite a bit, yeah.
Yeah,
so the above domain, surprisingly, is actually, it's reasonable. I mean, it's not great, but there is quite a bit of constraint from the surface sites. There is almost like you can end up with like this ring of surface sites that does a pretty good job at constraining. And we had noticed this like previously when we had compared, like even from the OCO-MIP world, when we compare the in situ versus the OCO2 based estimates, like there is difference, of course, in the seasonality and the net uptake, but in overall, like it's not like a terribly under constrained region, like, the tropics or some other place. You cannot say the same for Siberia, because that becomes terribly under constrained where there is hardly any in situ data.
And Lei, while I have you, for the carbon tracker methane, how much, I actually don't know carbon tracker methane as well as I know the regular carbon tracker, but is it the same in the sense that you're ultimately adjusting entire sort of ecoregions at a time?
So the new carbon tracker methane uses Suresh Basu's optimization system, which do grid scale, I think 3x2 grid scale globally, and it includes isotopes.
Okay.
Okay, and I'm just looking at the chat. I see questions being answered. Yes, Lei, that's a good point. I think, there is some nuance in saying whether it's like carbon neutral, slight net sink or slight net source. I think, again, it kind of just, what I'm noticing is that you see those terms changing a lot depending on the particular combination of data sets that you are using. And certainly, I think once we have like the final pool of data sets that kind of goes into the manuscript, depending upon that, we'll sort of make sure to identify that, or sort of like make sure that we use the right term.
Yeah, Abhishek, do you mean the mean doesn't vary a lot, or do you? Yeah, because when I look at your slides, it seems like in each component, like the
uncertainty is really high. It's huge.
Yeah.
And a lot of that, especially on the NPP NE part, a lot of that uncertainty layer was coming from the trendy models.
Oh yeah.
Because and we had like many more sort of trendy and other than trendy, we really had like just SIP4 and the regional ed from Eric Larson. But almost all of that big range that's basically coming from the trendy models. The atmospheric inversions were actually surprisingly, for at least for CO2, were a little bit more tightly constrained. And then the upscaled ones, we had only like two, N is two, right? So that wasn't like a lot there to begin with. But yeah, I'd be really curious to, it would be great if we could get your inversion estimates now that you have it.
Yeah, I would be happy to share that with you. Another question. I'm not sure whether it's useful. Like we started to have estimates on GPP using COS. I don't know whether that could be useful for your analysis and whether you're interested. The time period is a little limited as it only covers 2009 through 2015.
Okay. I mean, it is certainly useful in the sense that it's a good, I mean, that's a much more constrained estimate of GPP, right, with the COS data. Yeah, certainly send it. I'm not sure how, like within the budgeting activity, how I would pull it in, because it's sort of easier to have, or I mean, it's kind of better if we have the NEE, NPP there. But I guess you're also backing out something for respiration, I'm assuming. Or
yeah,
are you just
because we have CO2 informed NEE, so we can back calculate the respiration term. Yeah.
Yeah, it's like a smaller period, but certainly I'm happy to again take a look at it because with sort of like the updated data sets, I wanted to go back and sort of redo the comparisons we had done against the flux towers, because again, those are pretty old and done a while back. And so I was just going to kind of redo some of those comparisons again. So yeah, certainly.
I had one other question. So Abhishek and I have talked about this a little bit offline, and Leah, I know you've been chatting with Wu, but all together, what is the status of footprint availability for the above domain? And in the context of your paper, Abhishek, can those be used as an additional assessment of all the various models and inventories that you're assessing, and even the inversions, right? You could still compare those to the broader set of sort of non-long-term tower observations in the above domain or around the above domain.
So for
yeah. Go ahead, Lei.
So for the footprint status, we have multiple sets of footprints now. For the ones your group have been used in the past, the Wharf Steel footprints, they are available from 2007 through May 2018, and we are in the process of updating that set of footprints through 2020. So we are.
But that's for that same set of Environment Canada and long-term NOAA observations, right? Or do those include all of the more episodic and airborne observations that were part of the above studies?
I'm not full. So for that regular updates, we generally update our long-term sites. We do have a second set of footprints that's funded by the ABoVE project, phase 2 project, which covers all the Arctic Cap, the ABoVE campaign for 2017, right? And it also a continuation of covering the curve. I think there's a few months that was not covered previously. So that's kind of covered through the new project. And there's, let me see, and there is also footprints for the OCO2 satellites from that project that covering the above domain.
Are those sort of consolidated or put together in an easily accessible place across all of them?
It's on the ORNL.
ORNL DAC.
Yeah, DAC. Yeah, I think I sent you the link before.
Yes, I can confirm I have the link to the above footprint.
So there.
So sorry, just to follow up, because I feel like I've heard sort of mixed things about sort of how much of. I remember at the January above PI meeting, there was a lot of discussion about time periods and observations for which footprints were not available. So, and I'm just sort of exposing my ignorance. Are there sets of observations for which footprints are not available, or do we have footprints for everything essentially up to very recent times?
Yes, so the new set I mentioned to you, it's actually a continuation of the CARF campaign. So it's actually having the 0.5 degree resolution from 2012 through 2020 for any in situ measurements that occur in that period, and we have additional OCO2.
Luke, did you want to add something?
There haven't been any CARB specific measurements since 2017, so there's no additional observations, and there won't be any footprints for those.
Yes. CARF above, CARF Arctic Cap for the campaign, and there's long-term sites, the long-term in situ sites from the NOAA and from Environment Canada that do cover from 2017 through 2020. Look.
So it kind of seems again like there is just like a mix of different observing systems and a mix of different time periods for which when footprints are available. I mean, at some point it might be useful. Yeah, I see this coming in the chat, like trying to put together like a table or a list of what's available, and making sure that all the observing systems are covered. Because it doesn't sound like some of the aircraft data is certainly there, and maybe some OCO2 data that you mentioned, Lei, some of the in situ measurements. But yeah, it would be good to kind of have just know what's available.
Yeah.
So leading off of that, our next planned meeting will be sometime in October. John and I will be sending out a when to meet poll. I think, Luke, if you're available, we would like to have you maybe take 20 minutes and present on some of the activities from our phase 3 project, doing the polar WRF still bottom up versus top down kind of diagnostic comparisons. But that meeting might be a good opportunity if there's a volunteer who would like to take another 20 minutes following that to talk about footprint availability and atmospheric data availability within the region, both core above domain and then maybe extending even further into other parts of Canada. So if we have volunteers, please let John and I know. We'll sign you up for that.
And
I can
I'm not trying to volunteer, but I wonder if this is also like a Google Doc task or just an email task, right? Where it sounds like there's more available than some people are aware of, and so be very helpful to collate everything. And it sounds like, Lei, you might have the most sort of comprehensive knowledge of everything that's available. And then I still don't know how compatible all of these are with each other. But anyway, maybe we can touch base offline. But I wonder if
yeah, I mean,
yeah, go ahead, Abhishek.
No, I'm just like looking at like the things that are being put in the chat. Sorry, no. I was just going to volunteer that. I mean, I can certainly put together or start that list for the atmospheric data, since we have done that multiple times before. I remember back in the day, I think we had started putting together Liz, that Megan was sort of maintaining of all the different atmospheric data that we could collect over the domain. So I think there is something that's there that we can start from.
So my thought, Abhishek, if you are willing to start a list, like a shared Google Doc that we can all take a look at in preparation for our next meeting in October. Lei, would you be willing to lead the discussion and just a brief overview of what we have found with footprints and what's available?
Oh, you want me at least like compile lists of footprints for the
Not
ABoVE?
necessarily, but maybe lead a discussion if Abhishek starts putting together a list of footprints that we can all
And I don't want
contribute
to sort of, yeah, and I don't want to sort of over volunteer people, but you know, Wu, who's online as well, and so for Wu's and my project, this is a pretty high priority item as well. So I think we would be willing to either help, you know, ping people and compile a list and coordinate with you, Lei, and Abhishek. And then it doesn't much matter to me who leads the ultimate discussion. But I think if we had like this, if we had like a understanding of all the data that are available, whether there's footprints and any specific details, because some of them I think are, you know, worth still, some of them might have used her data from conversations I've had with other people. I don't know how consistent the boundary conditions are. I don't know how consistent the domain and the resolutions are. But if we could hash all that out, and I think it's really a relatively limited group. I think Roisin, based on the chat, obviously you're super interested in as well. And then I think Scott Miller's group was quite interested, although I'm not sure if anyone from his group is on the call today. But anyways, I guess what I'm suggesting is maybe if Lei, Abhishek, Wu, and I coordinate offline, I suspect we can figure this out.
Excellent. So we'll have you report back and let us know how you'd like to structure the 20 minutes at our next meeting.